Okay, once more with feeling. I'm going to record this templating lecture again. This is going to be the second part, so I confirmed that that was the one that was broken. So I get to replay all of my I screwed up this last lecture and now I'm going to fix it comments that I gave last time. So let me double check first before I get going. I want to check to make sure that it now shows the right thing. It should say changed or void and intersect. Okay. It looks like it's actually changing things at least. What happened last time? So I'm going to fully admit the last time we did this, I was trying to, I was like, no, there's no way that C++ is that silly. I must be misremembering things. Maybe my lecture slides are wrong. I say, you know, that, and I even say in my slides that everything must be put in the header file. And I go, there is no way everything needs to be put in the header file. That must be just sort of like on a Tuesday, some weird edge case. No, the syntax for C is as insane as it sounds, or C++ is as insane as it sounds. The issue, it's you won't see this in a lot of other languages or some other languages, but as a sort of a side effect of how they actually build things with a header file and a CPP file. In order to make a templated class, you have to put everything in the header file because otherwise it won't know how to hook it up properly. It's an aspect of the language itself, which is a little strange, a little disconcerting, if you will. So the idea is this. I'll go back over to what I did. So I merrily started migrating everything over, putting templating stuff everywhere because I knew I was going to need to do that. Except I didn't. So here's what. Let's look at my code. Actually, what it looks like over here. Here is the demo file with the CPP file. Here's my payload object. That is all. Okay. I literally, in the very first time I recorded this and things hit the fan, so this is actually my third attempt at doing this particular lecture, by the way. The first time I tried to do it, I intentionally deleted all my CPP files when migrating things over. I deleted all my CPP files, and then I got into the wackiness that is operator overloading and that sort of stuff. So by deleting my original CPP files, just to demonstrate, I actually don't have CPP files anymore. I don't actually need those CPP files anymore. I just need to include those header files. The header files have the full definition for each of my objects. Now, if I make any change in that header file, no matter how insignificant that change is, it means I have to rebuild everything. The reason we separate header files and CPP files is because I want to have just these are the functions that you're going to have available to you, not how they're defined. I want to sort of separate the declaration, these are the options available, if you will, the blueprint that you can use, and here's actually the gory details, here's the implementation details. I normally want to separate those out, but as a side effect of templates, I actually can't do that. I actually have to see how they're being implemented. I'm not sure exactly what the standard template library allows you to do or doesn't allow you to do, but I'm sort of curious and wondering if you can actually just directly look at the code that they use for the standard template libraries, because it all has to be in the header file. Anyways, neither here nor there. Let's have a quick look at it. It looks just like we would normally have for a header file, right? Here's a variable that we're going to use. I'm using showing that it's a templated class right here. So the class, I'm going to have some class T that's going to be stored in here. So I'm going to make a linked list node which stores class T in there, right? I have to put T's everywhere. Everywhere I would have had my original variable type, which was an int, or every single thing that possibly might be dealing with that this template, I have to say, yeah, it's going to take in something. It's going to take in some class of type T. What is that class of type T? I don't know. I'm going to figure it out later. That's actually where the benefit and the problems with templating is. Essentially, I'm saying I'm taking in some kind of class. I'll figure it out later based off of how I use this thing. And that's the second thing that got me into trouble. The first thing was not putting everything in the header file. The second thing was I painted myself into a corner. When I made this original linked list class, I didn't realize it at the time, or it didn't dawn on me at the time. When I made the original linked list class, I'm just storing a bunch of integers. And then later on, I wanted my code to just be able to do cout statements and print out what was in those various nodes. That makes it a lot harder later on to template this, because it means, let me have a look at, where is it now? Let me go down to the bottom. I'm going to check to see if it actually is still recording the screen again in a second. Remove the end, remove start. I want to see where my printing method is. Print list. So when I'm doing my print, I'm going to each node. I'm going to so my print list method goes to each node, says get the data, and I'm going to output the data in the cout statement, right? So I'm outputting the data. I'm going to get it. I'm going to put it in a cout statement. But that involves, so whatever data I spit out for get data has to be coutable, essentially. I have to be able to call cout on that thing. So strings work, integers work, random objects, not so much. So any object I make needs to be able to be used with cout, which means I need to override this particular operation. We'll see this in a second, but that is the requirement that one of the requirements all of my data have. I need to do this. I'm also going to, if I wanted to sort it like I do with insert, where's insert? Insert's down here somewhere. Well, actually, let me just show you in action. So I'm going to get rid of this operator right here. This is me defining what greater than or what less than actually means. So we actually did, so I'm going to, every time I call, let's say, payload, some object of type payload, is less than some other object of type payload, I want to see if this payload is less than the other payload. I need to override this. I already have that with integers. I could say int x is less than int y. This object is less than this other object. What does less than mean? Well, in terms of payload, I'm just checking to see what the values are. Is the value stored in this object less than the value stored in the other object I'm comparing it to? But I want to just comment out that line. I'm going to go to my payload.h. I'm going to comment out. I can also, by the way, override what equality means as well, and what this operator here is. And boom, it should blow up. It does blow up. This less than function is saying I don't have a way of using the less than function. The less than operator is not defined for this object of type t. Every single one of my things, if I go to my linked list, here's linked list, and I go to the function insert. It's insert start, that's insert end. I want the insert in a particular order. No. Where's my linked list should insert it in the right place, but I don't know why it's not doing that. Insert after, there it is. So this line right here, and let me confirm that this line is actually showing up. So I'm going to move this. I'm going to move this over. Just make sure. Yeah, okay, it's recording properly. Anyways, here I am. I take a particular. I take two pieces of data, and I'm checking to see the thing I'm going to add. So let's see where that is. My linked list node to add. I'm going to check to see if that linked list node is less than the current node. And what is less than the current node? And so if I go to my linked list node itself, I can, here's my operator. I'm checking to see if the data, here's data 1, here's data 2, essentially the payload, the thing that's stored in each of the nodes. And I'm just going to check to see if D1 is less than D2. Now that worked just fine when it was an integer, right? Each of the nodes have a number. I'm just seeing if number 1 is less than number 2. But if I have an object stored in here, I need to make sure that that object can compare itself, which object comes first, this object or this object, right? Which string comes first, this string or this string? Which student comes first? If I have a bunch of students that I'm trying to put into a linked list, which student comes first? Maybe it's based on the student ID, right? The student with this student ID comes before the student with this student ID. If I wanted to sort this this linked list, that's what I need. I need to be able to compare things. You'll actually see this lesson operator being absolutely critical when I call sorting functions in assignment 6. That I cannot put anything, I cannot call the sorting functions with any object of a particular type unless it supports this lesson operator. That it can actually check to see if this comes before that. Right? How do you sort it unless you can compare if something comes before the other thing? So that's what this, I'm going to have this operator here that I'm overloading. Uh, I'm overloading the operator for the linked list node, and any data that's actually stored in the node, my payload if you will, needs to be able to compare whether it's less than another one. So it worked fine with integers. Now every single time I put something else in there other than an integer, it still needs to work. Okay. So back to what we were doing before. Every single place. So originally I'm going to say, by the way, the class I'm dealing with here is templated. I'm going to take some kind of data of class T. What's T? I don't know. Based on what I call it, that's what it's going to need to be, right? So I can't put it says this is what I make requirements of the data I'm storing on it, not the other way around. I don't change my linked list for the data. I change my data to fit into my linked list. So I cannot store anything on in this linked list unless it supports the lesson operator, the ability to do a cout statement, and I think equality as well. So I'm saying I'm going to template this particular class. Notice I changed the name from before. We had another example where we were using type ref or something like that, some other syntax. I find the word just template class T a lot easier to keep in mind. Everywhere I would need to point out, like this linked list also stores that type of type T. I put the angled parentheses with a T in there. I can keep on going down and I can see, so this doesn't change anything at all. Here's the data going in. It's a linked list of type T. I got to put that T in there. I can keep on going. I'm storing linked list of type T, for inserting at the start. I'm going to make a virtual method and I'm going to make a particular node and return it. And that node is of type T, a linked list node of type T. I have to go through all of my code and see when whatever linked list node I'm using, I have to say it's of type T, because both of them only store the same kind of object. The linked list and the linked list node both have to deal with what kind of data is being stored. All right. And so most of my code does not change. All I need to make sure I keep on doing, here's me adding the data. Here is, where's get length? Do I have this particular node? I pass in the data and say, do I have a node that is currently storing that data, right? But I have to pass in data of type T, right? Class T data. Oh, that's the only thing I can check against. I have to go, I'm just taking all my code, putting everything in the header file. Notice my header file has a particular look. I don't have that double colon thing, but it looks like the other header files, except I don't have this double colon. It's indented like the other header file, my normal header files, except the entire code, the declaration and the definition are both in the same place. All right. And everywhere I'm dealing with something like, here's my I have to change my iterators as well. They will take data of type T. They're iterators for linked list nodes, which are linked list nodes that hold type T or class T, right? Everywhere that was touching one of these things, the data itself has to be templated as well. Because if the linked list is templated, the node has to be templated, the iterator has to be templated, everything has to be templated. So doubly linked list node, oh wait, that also has to be templated. It's extending linked list node, doubly linked list node, it's extending linked list node of type T, and it stores data of type T as well, right? It just propagates and cascades over everything. Okay, now let's actually have a quick look at what this thing actually does. So here is, oh, and here it would be me templating a particular function. This function, this is what I originally was thinking. This function, since it's only in link L08, it's not part of a class or anything. It's just a function sitting out in space, not in a class. I can template an individual function. It just cannot be in a class. That was what my confusion was. Okay, so this function is a templated function. It takes a linked list of type T. It will print out all the values from that linked list. Same as it did before. I just put T's everywhere instead of int. Everywhere there was an int, it's T. And all these templated things will also get a T. Here I am. I'm going to make my stack. I'm going to make a stack. It's going to store a whole bunch of payload objects in it. That's how I would declare this, right? Before I was just saying I'm making a new my stack, but it only stored integers. I'm saying this is a my stack and it stores this kind of object, payload objects. I'm going to make a bunch of payload objects and then push them on the stack, and then I'm going to print the stack. None of that code has changed. Before, what I had was I was storing a whole bunch of integers. Now I'm just going to make a bunch of different objects, store them, and push them on the stack. Nothing has changed in my original. Once I've templated it, I can put any object that I want, as long as it follows the pattern, onto this thing. I can make a new payload class called payload2, and it could also be stored on there. Or I can go even further, or I can take a different approach and say, I'm going to, so this is another payload, a linked list of payloads. Fine. Let's change this around. I think I did that already. Let's change this around. So instead of a linked list node, I'm going to make a and instead of this, I'm going to put int in there, and I'm going to put an int in here. Test. It's a new linked list, and so I just want a one linked list of type that holds an integer. All right, and all right, so I'm going to make a brand new linked list that stores a bunch of integers, and I'm going to list test, and I'm going to, so it's actually not an A. Okay, p list test. So this is a linked list storing a new linked list. Okay, and I don't think I need to put anything else in there, so let's plop that down. Let's plop this in, and then I'm going to say add or the value 40, let's say, and let's put a couple of these things in there. Print my list. All right, and I'm going to do a simple cout statement. Like list with integers. Okay, end line. All right, let's give this a try. Hopefully it'll compile. Oh, I didn't add this back on. My payload has to be. It didn't. Again, the reason I got an error was payload.h and payload.cp did not implement a function for checking to see if something's less than the. It's one of the requirements. My linked list or my linked list node use that operator. They test to see if one payload is less than another payload. So I need to implement that function. Might need to implement the equality option, the equality operator. I definitely need to implement this operator to be able to call cout. Now that is weird syntax, and I looked long and hard. It was like 45 minutes looking for this syntax for this stupid thing, right? In order to, and I will not be asking for that on an exam, by the way, right? The ability to override the cout statement is actually a lot more convoluted and quirky than I wanted it to be. I should have probably had some kind of print statement, but then I couldn't just use an integer. I couldn't just store integers on this thing because integers do not have a function for printing out stuff. So this is me attempting to work around a constraint I put myself under. Payload CPP. Let's comment this out. Let's comment out this. All right, it builds. All right, and let's see if so. I have a horrible printout. Linked list, no, linked list with integers, node 20, 30, and 40. Oh wait, that's exactly what we had. I'm now storing integers here. Oh wait, I'm now, instead of storing integers, I'm storing a bunch of payload objects in there. I can store whatever the hell I want in my linked list. Now, templating allows me to put different data types in my structures, in my linked list or my stack or whatever I'm using. Now, if you want a better example of linked lists, look at the other linked list. I think it's linked list of lecture 11 linked list templates or something like that in the shared code repository. That one's a cleaner, smaller linked list class because I wasn't making stacks and this and that and the other doubly linked list. It was a much smaller code base in it, so it might be a bit easier to get your head around. But both of these will work. It's just since we've been working on this code base for the entire term, it's gotten a bit long in the tooth. It has a lot of stuff going on. So in case you're a little confused, there's another example also in the repository. All right, to also finally look at what we're doing here. Again, this is me overriding what the output statement here does. And if you wanted to see what this actually looks like, I think it's linked list node, and I think it's print data, or it's get node, and then okay, if I'm getting the node, then I can print off the data in linked list. I get the data, and then once I get the data, I'm just putting the double chevron signs, the double angled brackets thing here, to output it to cout. In order to do that, all this is doing, I just get data here. And so therefore, this function here has to know how to deal with the cout statement. And that's actually what I have. This is what the problem was that I had with payload.cpp and payload.h. I had to say, hey, if I need to override this operator, it takes in an IO stream, an O stream, it takes in some kind of payload. Notice it's not even a member function, it's just a function, a friend function that takes in the O stream, the output stream, the payload, and then returns an output stream. It was weird and convoluted, so don't panic too much about that. The point is, I want to be, sometimes this might be something useful to look at, for example, for your homework, but not the cout statement. Your job is to, for the hash table question, is to play around with this, and it's much smaller in terms of scope. Your hash table is going to store in a bunch of variables, but you want to maybe store integers, or you might want to store different kinds of objects. You might also need to be able to check to see if the value, if you're trying to template this thing, you need to be able to make sure that it can take in any. You need to be able to run a hash function based off of call a hash function, or get an ID or some kind of value from the thing that you're going to store in the hash table. That would be a requirement. Every single class of type T has to support that, because otherwise it can't go on the hash table. I might want to print it out to the screen, but or at least get the value in some printable format. So have it return an integer, or have it return, have it return value is the name of the function, and it returns some integer, right? Whatever allows it to work for you. Your templated objects will have certain set of requirements, but those requirements are not overly necessarily that crazy. And so I'm going to do another video soon on what kind of requirements that's going to need. The big takeaway here for all of this, if you're templating, first, everything has to be in your header file. If it For every single class that is templated class, everything has to be in the header file, which I still find bizarre. Anytime you want a templated function outside of an object, you can do this. This is me doing the horrible linked list print function that I had before. Uh, Within a particular object, not only is it in the header file, I say this is a templated class at the very top, and everywhere I potentially might need to know that something is templated, I put a T in angled brackets, and it goes everywhere. It's a lot of find and replace. Your templated, this will tell the system when you're compiling, hey, anything that you're going to put in this structure or in this object, like a linked list, has to meet certain requirements or criteria. Like I have to be able to test to see if it's greater than another one, or perhaps I need to be able to call the plus operator, or add two of them together, or whatever the case is. The functions that you have in your templated class, anything that's stored in that templated class will have to match a certain set of criteria based off of what you do in your templated class. And as a result, you'll have to think about long and hard about what you need your templated objects that you're storing to be able to do, and then how to implement all of those parts. So it is, you make your templated class, and then afterwards you have the objects the objects that you're storing in the templated class have to match certain criteria. I won't be grilling you on templated objects on the exam like in a lot of detail, but it could be a multiple choice question or something along those lines, or maybe follow the example. So get comfortable with it, but I'm not going to ask you to memorize or ask for memorization on exactly how to write a full templated class. Okay, I'm going to leave this here before I have to before the sound cuts out again. I have to record the whole thing again as well. So have a great night, everyone, and hopefully this clarifies things a little bit. Thanks.